All right, so before going into the whole blocks thing, I just want to make sure that when you're using a calculator that you're not familiar with, or just as a double check, make sure that it's on the right mode. Because you would expect like, okay, 3 divided by 6, I'm going to go ahead and hit, equals, and it should give me the right answer. And what ends up happening is you get something like 500, and you're like, whoa, what's going on? It's just because you're in the wrong mode. If you don't know how to change it, then just call me over. So if you see something like RAD or GR something, call me over, and like I said, I'll switch it so that it's back to DEG. Again, you don't have to worry about what any of that means. You just need to be in the right mode. So like I said, there's all these kind of crazy settings on some of these calculators. But just as a double check, like I said, what you should be looking for is just DEG, like on this one. Like this one's set right. So now when you go ahead and hit enter, now it gives you the right answer. So we'll start off with that. All right, now that we got the calculator thing sorted out, we have our triangle, and we have our blocks over here. So first thing, in order to calculate density, okay, I'm covering up density, we need mass and volume. So over here on our block, mass is, well, how much does it weigh? Again, we're pretending this has grams, so we're saying 2 grams. Volume is how much space it takes up. So this is when we have to put it into the water and see how much the water level changes by. Now, notice it starts at 100. If I put my block in, somebody might say, oh, the volume is 2 mLs. And that's wrong. It's not 2 mLs. Why? It's because you're only seeing how much space this part takes up, how much is in the water. This is a problem with objects that float. You have to take the object and sink, dunk, or drag the entire thing to the bottom in order to get the volume. So now that I'm looking at it, it started off at 100 mLs, and now it's at 105 mLs. That means that the volume of this object is 5 mLs. So all I need to do now is, on my calculator, I just need to do 2 grams, okay, because that's how much it weighs, divided by, and then the volume, again in this case, it's 5 mLs, and that tells me that the density is 0.4 grams per milliliter, or 0.4 grams per centimeter cubed. That means if I pulled out one little tiny cube, a centimeter cubed, it would weigh 0.4 grams. All right, let's try it with another one. Okay, same volume, right? Because this is the same volume button. Starts off at 100, it goes to 105 milliliters. So the size of this is 5 milliliters. What's the weight? Okay, or the mass? 6. So I take 6 divided by 5 milliliters, okay, because that was the size, remember? And it gives me a density of 1.2. That means if I pulled out one little cube out of this, it would weigh 1.2 grams. And notice that the size doesn't tell me if it's going to sink or float. Look, these are all the same size, and some of them sink and some of them float. So volume by itself doesn't tell me if something's going to sink or float. All right, let's move on to same mass. Okay. So now these all have the same mass. They all weigh the same thing. So the number on top, mass, is going to be the same because they all weigh the same. So it's going to be 5 grams on top. Now what's different about these problems? It's the volume, the size. All right, so let's take the red one again. So we're taking the red one, and it starts off at 100 mLs. As soon as I put it in, it goes to 1.25 mLs. Okay, that's how much space it is. So again, from 100 to 101.25. So how much space does it take up? 1.25 mLs. So this is easy. Look, I'm taking 5 grams, dividing it by 1.25 mLs. So again, I can see that when I drag it in, 100 to there. And that gives me a density of 4 grams per milliliter, or 4 grams per centimeter cubed. That means out of this red one, if I pulled out 1 cube, it would weigh 4 grams. That's all it's saying. All right, what about this yellow one? Okay, so I'm put the yellow one in. All right, so what is my mass? 5 kilograms. Oh, is my volume 5 milliliters? No. Again, it's a floating object. Drag it down. Take a look. the volume is 10 milliliters. So now I can be like, okay, 5 grams divided by 10 milliliters is going to give me a density of 0.5 grams per centimeter cubed. And that's how you do the blocks. All right, next one, same density. So all these, the answer is going to be the same. So density, what basically this button is saying is density is going to be the same for every single one. But notice the masses and the volume are all over the place. Okay, so here we go. What's our mass? 1 gram. I can see that on the red block. Okay, how much space does it take up? Let's dunk it in. Oh, it takes up 1 ml. Wrong. If it floats, you got to drag it to the bottom. And I think this is where people mess up. The volume is 1.25 milliliters. So in this case, you take 1 gram divided by 1.25, and it gives you a density of 0.8. All of these are going to have a density of 0.8. So all of these are going to float. Okay, so watch. Again, it's a floater again. Okay, you might think that it's 4 mLs. It's not. Again, I got to drag it down. Okay, it's 5 mLs. So look, 4 grams divided by 5 mLs. Guess what? It gives me the same density, a density of 0.8 grams per ml. So how do I know if something's going to float or sink? So let's go to our custom. So if you look at the density up here, look, it's 0.4 kilograms. It floats. So let me change this to a custom one. So look what happens, okay, as I increase the mass, but more importantly, look what happens to the density, okay? As soon as I'm over 1, look what happens. It starts to sink to the bottom. As soon as I'm less than 1, it's a floater. So this is a key concept. Anything that is more than 1 gram per milliliter is going to sink. Anything that is less than 1 gram per milliliter is going to float. Now somebody out there is going to ask, well, what happens if it's exactly 1? We'll talk about that later.